Hello, Professor. My name is Niharika. I'm here today to talk about applying random forest algorithms to predict if road accidents occur more in rural or urban areas. So, these are the table of contents. First, I will be giving the introduction about the algorithm, the problem statement that I've considered, and how the algorithm works for each iteration, and the application of the algorithm to my problem statement, the results and the metrics that I've received, and finally the conclusion. So, with the introduction of the algorithm goes this way. So the random forest algorithm was introduced by Leo Bremen in 2001 in one of his papers titled Random Forests. He proposed the random forest algorithm to improve the accuracy and robustness of decision trees, which were the popular machine learning method at that time. The basic idea behind decision trees is to partition into multiple input spaces. These decision trees all together form a random forest. So the decision trees is built upon evaluating the conditions. So this is an example of a decision tree. So the root nodes are decision nodes where the partition will be happening like so. And a decision tree is used to categorize or make predictions based on how a previous set of questions were also answered. Like here, for example, if the age of a person is less than 30 years and he or she is graduated from college, then the income, based on the income or height, in the end, we will know if he will be buying a particular product or not. So this is how a decision tree works. In the end, there won't be any exact in output, but there is some approximation given in the end. So this is how every decision tree is built. All these decision trees together form a random forest. So in the beginning of the algorithm, a random forest is a classifier that contains several decision trees on various subsets of a given data set, and it takes the average of to improve the predictive accuracy of that particular data set. So the algorithm randomly selects subsets of the training data and different features to build each decision tree. So after that, it finally, takes an average of the prediction, or sometimes there are two kinds. One is classification, and the other one is a regression. So in regression, it usually takes the final highly voted decision. Apart from that, in regression, it takes the average of the votings that are in the end. So this is how a random forest algorithm works. So we train the data in multiple subsets, and we create the decision trees. And based on the decision trees, we take the average of the votings. So that is how prediction is done in a random forest algorithm. So I use this algorithm on my problem statement. So my problem statement is that we usually take a huge piles of data sets. So this random forest algorithm helps in representing the data sets graphically, and using other visual aids, we can show the relationships in a more readable and a meaningful way. For this, we make use of various libraries available in Python. So for my problem, I'm trying to predict the accidents occurred more in rural area or in urban area. So there's going to be one input, which is like a speed limit, for example, in my case. So if I give the speed limit, we will be able to predict whether the accident took place in rural areas or in urban areas more. So that is my problem statement, and the iteration of the algorithm goes like this. So a random forest algorithm is an iterative algorithm that builds multiple decision trees using samples of training data and randomly selected subsets of the features. Like I've mentioned before in the diagram, we take multiple training data sets, trained data sets. Sorry. So input is the data points. So we take data points from the data sets. It is like a single row or a single column, and we give the data sets the data points as input to predict the required output. So in each iteration, a new decision tree is built using a different random sample of the training data and the different subsets of the features. So the goal of the algorithm is to create a tree structure that can accurately predict the target variable for new data points. So every time I given a new data point, a new decision tree is created, and in the end, a prediction will be done. So based on every prediction, in the end, we finally come to a conclusion. The application of this algorithm on my problem is done as follows. This is the example of my data set. So there are weather conditions, speed limit, urban or rural areas, sex of casualty, age of driver, and vehicle type. If I want to predict if the accident took place more in urban or rural areas, I given the input as my speed limit. So if I given my speed limit, the decision tree selects if it's going to be more, if it's going to be in the urban area or rural area, like so. So we given one data point, and it makes a decision based on that data point. So the data set is, this is like a pseudo code for the application that I've done. So the data set is first pre-processed to remove any missing values in the feature and other empty values that are there. And the feature variable is set as speed limit. That is the main variable that I'm giving in my as my output. So speed limit is my input here, while the target variable, that is the output, is set as urban or rural areas. The data set, the urban or rural areas has only two values. It is 1 or 2, or it's like a binary value. It can be either 0 or 1 or 1 and 2 or something like that. Basically a true or false. So the data set is split into training and testing sets, and the random forest classifier model is initialized and trained on the training set. So once the model predicts the outcome and stores them using the randomly created decision trees, to predict a new outcome, the speed limit is fed into the trained model, and the target value, which is urban or rural areas, will be the output. So finally, the highest voted outcome is the final prediction. Finally, the data is visualized using the plots. Even if I don't want to predict anything, I can just take my data set and plot it in a different visually easy readable formats, like bar plots or scatter plots. In my case, okay, so before I talk about the visual representations, I'm going to talk about the results that I've received on my prediction. The most of the drivers are male drivers, and most of the victims escaped with minor injuries. And the highest number of accidents were on Friday, whereas the lowest were on Monday. And finally, the accidents, this is my final prediction, accidents will most likely occur in more urban areas than in the rural areas. So these are the graphical representations. The first figure is a scatter plot where it shows 1 is urban area and 2 is rural area. So based on the speed limits, the scatter plot is marked. And the accuracy and confusion matrix, the precision, recall, F1 score, support, these are used to give out the accuracy of the results that I've received, because the random forest algorithm is basically used to improve the accuracy, and this is like the most accurate algorithm that is used in machine learning. So precision is the ratio of true positives to the total number of predicted positives. In this report, the precision for class 1 is 0.98, which means 98% of the instances predicted as class 1 are actually class 1. Then recall is something, is the ratio of true positives to the total number of actual positives. So in this report, the recall for class 1 is 0.99, which means that 99% of the actual instances of class 1 are correctly identified. And F1 score is the harmonic mean of precision and recall. It is like the basic balanced measure of model's performance. And support is the number of instances of each class in the data set. So given the speed limit, here, this is the visual graphical representation after the random forest algorithm is applied onto my problem statement. So this is how the output is gonna look like. So once I've given in the speed limit as my feature variable, that is my input, and the target variable is going to be either 0 or 1. So here, based on the input, the speed limit, the prediction is that the urban areas are going to have more has more accidents than in the rural areas. Then then the second one is something like the another different representation where I've given the class of casualty, and it predicted that most of the drivers are male than female, and that is how the predictions can be done using the random forest algorithm. So finally, the conclusion, in the case of predicting if accidents occur more in rural or urban areas, the random forest algorithm works as it takes in a data set of accidents with multiple columns, which acts as factors in predicting. The fact that the random forests can be used for both classification and regression tasks help us in predicting what we're aiming for. So the algorithm pretty much takes new accident features and passes them through all the decision trees and stores each decision. Then in the end, the final decision is determined by summing up the predictions of all the individual trees. That is the end of my lecture. Thank you, Professor.